All right, Henry Benoff, Lab 7. In this lab here, we simulating a four-stage process um, hmm, using a button as an input, a red LED as an output, a green LED as an output, a motor as an output, light resistor as an input, and a temperature sensor as an input. And basically right here, what we got right here is that we basically we are declaring our global variables, which is a button, a red LED, a green LED, a motor, a light resistor sensor, and a temperature sensor. Um, the button is basically set as the button is basically on pin 2. The red LED is on pin 3. The green LED is on pin 4, and the motor is on pin 5. The light sensor is on A1, and the temp sensor is on A0. And down below we got our button press set at 0 because I wanted to put a counter in there. However, I did not put that counter in there. And in the void setup loop, we got the serial begin, which is basically nothing more than the communication speed between Arduino and the computer, set at 9600 baud. Here we're setting up our input and output devices, and we're using the pin mode function to do that. The button is set as an input, temperature sensor set as an input, light sensor set as an input, red LED set as an output, green LED set as an output, and the motor set as an output. And let's go on down to the void loop. In the void loop, as you can see, I got my count state there, which I slashed out because I'm still in the process of trying to use it. And I got my button states, which are basically a variable to hold the state of the button. My button state equals digital read down here, which reads the button. This right here tells me whether the button has been pressed, and it's going to indicate on the serial monitor as a 0 or 1. And once the serial monitor is brung up, it's going to say button state equals da da da, whatever the state of the button is. And here I got my serial print, or my serial print wait time as 350 milliseconds, because that way we can we are able to see whether to slow down the printing stages. In my if statement, I use if statements for this particular lab because it was pretty much easier for me to do. My if statement said basically here saying if the button state is equal to high, then digital read the button press and basically turn on the red LED. Turn on the red LED, turn the motor on, wait 4 seconds, and after you wait that 4 seconds, you're gonna turn off the red LED, turn the motor on, turn the motor off, and turn the green LED on, and you're gonna wait for 7 seconds. And after that 7 seconds, you basically is gonna turn the green LED off, and we're gonna go over here to my next stage, to the next process, which would be process 3, because I'm using my button as an input, and that's gonna equals 2 stages. It's gonna have to be pressed twice to get to stage 3. Here in process 3, I'm using I basically have a local variable here represent my light state, and my light state is going to equal to an analog read, which is going to read the light sensor, and then we're going to print a light sensor to light state is equal to on the monitor. And the second line is going to be the actual value of the light resistor. And then we're going to wait again for 450 50 milliseconds, and that basically tells us it's basically slowing down the print process so we can be able to see it. And for my second if statement, states that if the light state, which is the light value, is greater than 210, then you're going to turn the red LED on, you're going to turn the motor on, and then you're going to wait 4 seconds. And after that 4 seconds of wait time, you're going to come down here, you're going to turn the red LED off, the motor off as well. Then you're going to turn the green LED on, and then you're going to wait 7 seconds, and then you're going to turn the green LED off. And here, basically just like my second if statement, we got another local variable saying that that variable is representing the temp sensor state. And this variable right here is basically holding the state of the temperature. And down here it says temperature sensor state equals to analog read temp sensor is going to read the temp sensor. And I also have a map for my temp sensor to actually tell you the ambient temperature of the space that you are actually in. And then it's going to serial print the temp sensor state is, and then it's going to print the value, the degrees for you. Then it's going to wait 550 milliseconds. After that 550 milliseconds, we're going to go to our third if statement. If the temperature is greater than or equal to 89 degrees, then you're going to turn the motor on. You're going to turn the red light on. You're going to turn the motor on. Then you're going to wait 4 seconds. And then you're going to turn the red LED off. You're going to turn the motor off. You're going to turn the green LED on. And you're going to wait 7 seconds. And then you're going to turn the green LED off. So now we're just going to go ahead and step into this process of the serial monitor and show you what is going to be actually on the screen. Let me go ahead and clear that out for you again. And as you can see right now, the light state is at 35, temp sensor is basically at 87, and the button state is at 0. And we're going to go over here to our little microcontroller. That right there basically is my motor. My blue light is over there, and this is my input device, the button. That is my light sensor, and this is my temperature sensor. So once I press this button right here, the blue LED should come on, the motor should come on, and after 4 seconds, everything should stop, and the green light should come on for 7 seconds and then go off. So here we go. We're going to go ahead and press this button. Blue LED comes on, it's running for somewhat 4 seconds. It stopped. The green light comes on. And as you can see right here, let me turn this off right quick for you so you can actually see the state of the button. The state of the button right here is equal to 1, meaning that that button is high. So it provided power to the motor and the blue LED, which came on. And now for the second stage of this, we're just going to use the temperature sensor because I normally use the light on my phone to activate the light sensor. So we're just going to go ahead and go to the temperature sensor, which is right there. I'm going to put my hand over it to increase the temperature. Let me put this back on auto strobe for you so we can actually see the temperature. Okay. I'm going to clear it out again. So temperature right now is currently at 88 degrees in this house. And we're going to put our hand on it, on the sensor. See, it's at 89 degrees. The motor started. The blue light is on. The green light is on. And it's going to wait. And we're going to go off. And I'm going to put my hand back on Okay, it's still reading 90 degrees here. So as you can see, my temp sensor state is still 90 degrees. Okay, now it fell back to 88 degrees here, and everything is off. I'm gonna put my hand back on this temp sensor, so once it read 89 or equal to, it comes on, goes up, da da da. There you go. Thank you for watching this this YouTube video. Henry Benoff, Lab 7, processing with all types of inputs and sensors. I'm out. Thank you. Bye-bye.